This is a follow-up video to the trig ratios video, going over some of the harder problems you'll be expected to work. I only went over very basic problems in that video. This is some example problems on harder ones, and I'm just going to go through them quick so you have an idea of what to do when you encounter these. Let's start with this triangle ABC. It is a right triangle. We want to find the sine of angle B. As you recall, the sine is the opposite side of angle B. The opposite would be 55 over the hypotenuse. We don't have a hypotenuse yet, but we can use something we already know to find the hypotenuse. We can use the Pythagorean theorem. It still works. It's a right triangle. Again, Pythagorean theorem, a squared plus b squared equals c squared. All right, so we take our two leg lengths, 48 squared plus 55 squared. That's going to equal c squared. We're going to call this c for right now. We could call it x. We could call it anything. Well, 48 squared plus 55 squared gives us 5,329. I punched it into the calculator before I started. That will equal c squared. Now we do the square root of both sides to find c. C will equal 73. So we now know that this side length over here is 73. We can plug it in. So the sine of angle B is 55 divided by 73, or 55/73. We can only leave as a fraction. We're already simplified, okay? All right, let's go to the next one. All right, here we want to find the tangent of angle O. All right, as you recall, the tangent for an angle is the opposite over the adjacent. Quick reminder, the hypotenuse can never be the opposite or the adjacent side. The hypotenuse is always the hypotenuse. So, we look opposite angle O, and we're missing a measure. Let's use the Pythagorean theorem again to find it. In this case, here's what we're missing. We'll call it x. All right? So, x squared plus 32 squared is going to equal 68 squared. All right, now I did some of this on the calculator ahead of time. 32 squared is 1,024, and 68 squared is 4,624. Now we do our basic algebra. At this point, again, we're back to algebra 1. X squared is going to equal 3,600, so x is going to equal 60. We now know our other side. 60. So we put our opposite, which is 60, over our adjacent. Remember, the adjacent will never be the hypotenuse. The adjacent is 32. Reason I brought this one up, we got to simplify, okay? We still got to deal with fractions and simplify it. And I believe both of these have a common factor of 4, so I divide 60 by 4 and get 15. And 32 divided by 4 gives me 8. Okay? So the tangent of angle O is 15 over 8. All right, let's move on to this one. We want to find the sine of angle X in triangle XYZ. Now this one, we have all the angle measurements. We're not going to have to pull out the Pythagorean theorem to find something. This one's harder because we have radicals sitting all over here. All right? Let's set this up though first. The sine of x, of angle x, is going to be the opposite, 4 times the square root of 26, over the hypotenuse, 8 times the square root of 26. What's tricky about this problem is we can actually do quite a bit of simplifying here before we have to worry about anything else. In fact, all we have to do is simplify. The square root of 26 divided by the square root of 26 is just going to be 1. It's like factoring out. It's like crossing off the same number. So those are gone. All we're left with is 4/8. What does 4/8 simplify to? 1/2. A very complex number simplified down to a very simple fraction, okay? Look for opportunities where you can do that and simplify the problem earlier. All right, one more here real quick. All right. We have triangle WXV, and I did not indicate, and I should have, that this is a right triangle, just like everything else we've been working with. We want to find the sine of angle X. Notice what my instruction is here, okay? The computer and your tests are going to switch back and forth. Sometimes they'll want the answer in the simplified radical form, meaning we leave the radicals in, we don't compute them. But sometimes we'll get an instruction like this. Write the answer in decimal form, meaning we're going to compute all this out. We're going to round, in this case, to the nearest hundredth. Okay? It might say to the tenth, it might say to the thousandths. Okay? You got to read the question. All right. Now to find the sine of x, we need the opposite over the hypotenuse. So opposite x is another unknown. All right? So we got to find this. Let's just call it x. X squared plus, our other leg is square root of 82. We'll square that. Equals the square root of 93 squared. All right? Well, this actually simplifies really easy because if we do the square root of 82 squared, these just basically cancel out and we're just left with 82. You can double check that in your calculator if you want, but that is the way it always works. Equals, this will cancel out as well and give us 93. X squared will equal 11. So x is equal to the square root of 11. So we'll write that in right there. All right. So opposite of x is square root of 11. The hypotenuse is square root of 93. All right. Now, if we were talking simplified radical form here, we'd have to take both the top and the bottom times the square root of 93 and then do all our simplifying. But in this case, it just wants it in decimal form. So you just punch it into your calculator and get an answer. And I did go ahead and do that beforehand and found that our sine of x rounded to the nearest 100th is 0.34. Should have a 0 there to be absolutely accurate. Okay, did a few example problems just to kind of help you through.